Okay, so what is specific heat? So let's say we have two types of materials here. And we have 1 gram of material A. And we have another type of material over here, material B, and we also have 1 gram of it. And let's say our initial temperature at this point is going to be 20 degrees Celsius. And then we're going to allow two of these materials to increase 1 degree up. So we're going to heat it up until this becomes 21 degrees. We're going to heat this one up also, and it hits 21 degrees. And we find out that to do this, it requires, let's say for material A, it requires 10 joules of heat. And the other material, it requires only 0.5 joules of heat. Okay? So we've actually found out the specific heat of each material, meaning that for material A, the specific heat is going to be 10 joules is needed to increase 1 gram of this material 1 degree Celsius up. So that's written like this. So this is the specific heat then for material A. For material B, it becomes 0.5 joules are needed to increase 1 gram of this material 1 Celsius degree up. So that is specific heat. Okay, now so we have a table here which shows the different values of specific heat in joules or calories for different types of material. So for example, for water it's 4.186. So you need basically 4.186 joules of heat to raise 1 gram of water to a temperature change of 1 degree. Okay? Or you need basically joules to calories. You need 1 calorie of heat to do the same conversion. 1 gram of water and to increase it 1 degree Celsius up. This, by the way, is the conversion of joules to calories. There are 4.186 joules is equal to 1 calorie. So that is the conversion that is going to be useful in the future. So let's look at another substance. Another substance, let's say, is aluminum. So for aluminum, if you have 1 gram of aluminum and you want to raise it 1 degree Celsius, you're going to only need 0.9 joules of heat. So this does not take a lot of heat to increase the temperature of the metal. So that's why we use metal in cooking, because it'll transfer heat very easily. Meanwhile, water has a fairly large specific heat value, which is good because it actually makes the oceans and our bodies very stable. It takes a lot of heat to have a temperature change of 1 degree. Okay, so how is this useful in a thermochemistry problem? Okay, so let's say we have 20 grams of copper, and we want to go from 15 degrees Celsius and we want to heat it to 20 degrees Celsius. How much heat are we going to need? Well, in thermochemistry we have an equation. Q is equal to mass times the specific heat. This is the symbol for specific heat times temperature change. So just plugging in the formula, mass, we have 20 grams. Specific heat of copper, as we can see here, is 0.386 joules per gram degree Celsius. And the change that we want, the temperature change, we're going from 50 to 20. That's a 5 degree change. So doing this and plugging it into the equation, we figure out we need 38.5 6 joules of heat need to be added to the copper to increase the temperature by 5 degrees. We can also do another way. Let's say for this example, we have 100 joules of heat that we are going to add to this 20 grams of copper. What is the final temperature of this copper? So again, looking at the equation, 100 joules now is over on this side. That is our Q. Q is heat times the mass, specific heat of copper, we don't know the temperature change, so that will be our X. So solving for X is equal to 12.9 degrees. That is a temperature change. Obviously we're going to add heat, so the temperature is going to go up. So we're going to add it to our initial temperature of 15, so we add it to 15. We add this two together, and we get our final temperature to be 27.9 degrees Celsius. So, knowing the specific heat of a certain material is very helpful with us, because we can predict temperature change. We also can identify what kind of material we have if we have to find a specific heat given certain amounts of data. So that is what specific heat is.